Okay, nothing new today, just practicing the same thing from yesterday. That formula for using the derivative, we call that the difference quotient. And so we're just practicing using the difference quotient. I don't even have notes for you. All I'm going to do is on your homework worksheet, I'm just going to do a few of them with you. So grab out that worksheet. No need to write any notes. All right, I'm going to just start off with one quickie reminder from yesterday. Can you do this in your head in one shot? So let's give it a go. Here we go. Remember, you square the first term, but then I'm going to have to take it times the 5. So we should have a 5x squared. Now I'm going to multiply the 2 and double it. So that's going to be a 2xy times 5. And the last one is just going to be a y squared times the 5. Got to be able to do that. All right. Now this worksheet can be a little bit sneaky because they change on what they're asking and at what point do you stop and you do the answer. Now, can't be any easier. It's multiple choice. Every one of these, multiple choice. So, no worries. Here we are. Number 1. I am going to be super picky about showing neat work. So if there's no organized work that I can follow, I'm going to be counting it wrong. So here's our function. 3x squared plus 4. It says, which of the following limits will give the derivative? Okay, so here I go. I'm going to start off, and I would highly recommend you always start right here, top left corner as much as you can, because some of these are going to take some space. All right, so the derivative, that is a limit as h approaches 0 of, now we have this 3x squared. So remember, it's going to be, you do not have to, I'm going to hope you've done the difference quotient enough times. You do not have to write this f of x plus h minus f of x all over h. You don't need to write that. I'm going to assume we know. We're going to start off and we're going to take this x plus h. We're going to put it in for x. We're going to square it and take it times 3. So that's a 3x squared. Multiply the 2 and double it. That's 2xh times 3. And then square the last one. That's an h squared times 3. And then we still have to do the plus 4 at the end of the function. All right, that's f of x plus h. Now I'm going to subtract the function, which means I just subtract all the terms. And this is all over h. Okay, so this right here is the first step that I have to see. I've got to see the full thing written out so that I know that you've done all the algebra, you're finding a limit, all of that. The next thing I'm going to want is to see kind of what you've slashed, but I don't want you to obliterate it because otherwise I'm not going to be able to see this step. So I'm going to slash the 3x squareds. Then I'm going to slash the 4s. Those are gone. And then I think everything that's left has an H. So then your second step, keep this notation here. And simplify it. So this is going to become a 6x plus a 3h. Now, in this particular example, we should be done. It says, which of the following limits will give the derivative? Don't actually go evaluate the limit. Just right now you're done. So which of these match what we have? It looks like C matches what we have. Okay, so on this one, this is just number 2. It says here, again, big note, show all your work neatly. There's no skipping steps. I'm giving points for neatness on this and thoroughness. So this number 2 just says, evaluate the limit as h approaches 0 of this function. This is not a derivative. Nowhere does it say find the derivative. So we're not really doing that. This is what we did in the first couple days. We're just going to evaluate a limit here. So if you look at this, it's going to be a limit. Start top left here. as h approaches 0. And thinking back through our strategies, I see radicals, so I'm feeling like we're going to be doing the whole rationalize the numerator. One thing I'm worried about here is this 2 that's out in front. And I don't know, should I distribute it through, or should I just kind of leave it out there and worry about rationalizing? And that is actually a question, and we usually talk about it, and more often than not, people decide that let's just leave the 2 alone for right now, and then we'll come back to it. So, because that's typically what we do, that's what I'm going to do. I'm going to put the 2 out here and ignore it. But what I'm going to do here is rationalize. So what that means is multiply by the conjugate, square root of x plus h, and then do a plus sign, square root of x. Do it in the denominator as well. Okie doke. Now, again, assuming I'm just leaving the 2 out in front, now I'm going to multiply these 2 binomials times each other. So when you take this x plus h times square root of x plus h, square root of x plus h, the squaring of it and the square root undoes it, and I just have x plus h. And the reason we do the conjugate is because the outer and the inner are always the same, and they'll cancel, except one's positive, one's negative. So I'm going to skip that, and now I'm going to go to last. I've got a negative times a positive, and so a square root of x times a square root of x is just going to be an x. So I'm going to end up with a minus x. Okay, in your denominator, when we did this, this is a nice little review of this, that you don't want to take this h and distribute it into this. This h is the problem with trying to do my direct substitution. I can't do that. So my goal is to make that go away somehow. If I get it buried in here, I'm not going to be able to do that. So leave it out. We're just going to write it. So I've got h and then square root of x plus h plus square root of x, close parentheses. All right, now that's kind of my first step that I want to see. I want to see that you know how to do the algebra of that. Your next step that I want to see is your cleaned up version. So the limit's still there. I am not able to do the limit yet, so I keep it there, and I look at what can simplify. I see right here that these x's can simplify. Even if I were to distribute the 2 through, it would still simplify. It'd have a 2x and a negative 2x. So those are going to go away. So ultimately, I have a 2h left on the top. But since that h is getting multiplied by that 2, it's fair game to reduce with this h. So I'm going to go ahead and reduce the h's as well. And then all I'm going to have left is that 2. Nothing on the bottom. Okie doke. So now, once you have it simplified, my hope is that you're able to do your direct substitution. So I think we're going to be able to plug our 0 in. So at that point, when you're doing the direct substitution, that's the point where you stop writing the limit as h approaches 0. You've got your answer at this stage. So I'm just going to say that the limit is equal to, and I'm going to have a 2 in my numerator. And then when I plug 0 in for h, I'm going to have a square root of x plus a square root of x. That's a 2 square root of x. And that's my answer. And I go over here to my multiple choice to see if anything matches. It doesn't really, but that's because I still have these 2's. Those could reduce. And the other thing I notice is that I have a square root of x on the bottom that I could rationalize. But if I peek back up there at my options, they did not rationalize. They have a 1 over square root of x. And they don't have the rationalized version. So they must just want me to use that one right there. All right, now I don't want to do all the easy ones at the beginning, so we're going to jump to number 7 here. And this one, my hint is anticipate having to use the binomial theorem. The binomial theorem is the thing that says, hey, you could take x plus 4 to the 5th power. Remember how we do that? Okay, so knowing that, I might want to go ahead and build my Pascal's triangle for this. On this particular example, it looks like I'm going to be taking x to the fourth, which really means I'm going to be doing x plus h to the fourth. So I need to build Pascal's triangle to the fourth row. So let's do that real quick. So the fourth row goes 1, 4, 6, 4, 1. Okay, so now I'm going to start way up here top left. And this one says, let's see what our goal is. It says find dy dx. Okay, that's a little bit different, just different notation, but it's still finding the derivative, but it's that different notation. So let's practice using that different notation. It is still going to be a limit as h approaches 0 of, and now I'm going to do f of x plus h. So I have to put x plus h in for x. I'm going to take it to the fourth power. So think of it over here. It's an x plus h to the fourth power, but I also have to take it times 2 after I do that. Now, to take it to the fourth power is really just doing all of these. So there's going to be a lot of terms. We better write very, very small. And a shortcut on this might be to save the hassle of dealing with this 2 is what if I just went ahead and took this row times 2? And then I would know all those coefficients have already been multiplied by the 2. Okay, I'm going to do it. So here's what I've got. I'm going to write it up here. I'm going to have a 2, an 8, a 12, 8, 2. And then I am going to erase this because I'm afraid I'm going to need the space over here. I'm going to move that 2 so it's a little bit farther. Okay, so here we go. X plus h to the fourth power. All right, so remember the process. The first thing you do is you grab your Pascal number. My Pascal number has already been multiplied by the 2, so it's going to be a 2. X is going to be to the highest power. H is going to be to the lowest power. I go ahead and put the 0 there. Maybe you've done this enough time, you know that's going to go away. Plus. Now I go to the next Pascal number, 8. X is going to work its way down. H is going to work its way up. Next one, 12. X works its way down. H works its way up. 8. X, H cubed plus 2. X to the 0, H to the 4th. Okay, here's the thing. It feels like, oh, I got plenty of room, except I've hardly started. All I've done is plug the x plus h in here. Now I have to plug the x plus h in right here and take it times a negative 3. So it's like a negative 3 x plus h. So that's going to get me a negative 3x minus 3h, and then a plus 1. And now I'm ready to subtract the function. That's f of x plus h. So now I have to, I'm out of room. Sure enough, it's going to be a minus 2x to the 4th, a plus 3x, and a minus 1. All of that is my numerator, and this is all over h. Okay, so that's the first step I want to see. The next step is the cleaned up version. And at this stage, our limit should still be here because we have not been able to get rid of that denominator yet. Hopefully that's our next step. Okay, so looking for any like terms, anything that can cancel. What do we got? I don't think I'm going to have like terms off my Pascal triangle, but I have a negative 3x and a positive 3x on that. I have a positive 1 and a negative 1. Oh, this was kind of bad. See how I had a minus and then I wrote it down here? That minus really needs to be on my 2x to the 4th. And wouldn't this 2x to the 4th really be the same as this 2x to the 4th? Because the h to the 0 is going to go away. So I can cross that off. All right, what else? Okay, I think maybe that's it. And I'm just checking that I got an h that I can cancel on all of these terms that are left. And that one snuck in right there. Yes, everything has an h. So then your next step is to leave that limit there and write everything with that h divided out. So 8 x cubed, h would divide out, plus 12x squared, but this is going to be an h to the first power, or just an h, plus 8x squared, plus 2, x to the 0 is really going away. It's just going to be an h cubed, and then a minus 3. Okay, and that's with the h divided out. Now, since the h divided out, I'm able to do my direct substitution. Let's plug this 0 in right here. So that's gone. Here, that's gone. Here, that's gone. So then my derivative, after I do that direct substitution, is just what's left. So the derivative is going to be 8x cubed minus 3. Looking for an option? Yep, there it is. Option A. Got it. Okay, last one that I'm going to do with you. This is number 9. All right, look, fractions are your friend. But we need to write very, very small because this one's kind of lengthy. Now, first thing I'm going to do is say, okay, it looks like we are finding the derivative on this one, doing the whole thing, okay? And that means I'm going to be doing the limit. So let's start off. One of the things I'm wondering here as I look at this before I jump in is, do you feel like this would be easier if I combined these two fractions together and got a common denominator? Would that be easier to run through our difference quotient? You can see the answers, they did not do that, but I feel like it probably, if I don't do it now, I'm going to have to get a common denominator with an x plus h in there. And I'm not sure that that's going to be very nice to do. So I think it works both ways. I've tried it both ways. And I'm not sure that one is necessarily that much better than the other. But I'm going to go ahead and call this 1 over x plus 1 over x squared. The common denominator is just an x squared. So that just means taking this times x. I feel like this is not too bad to combine. So I'm going to have an x plus 1 over x squared. Okay, here we go. We are going to find the derivative. And it is going to be the limit as h approaches 0, leaving that limit in there, don't get lazy on me, of f of x plus h. And I'm really doing this one, right? F of x plus h. So I'm going to put x plus h plus 1 over, and I'm putting x plus h squared. Okay, I'm just going to write it, and you'll maybe see why here in a minute, why I'm just going to leave it x plus h squared. It'll probably eventually change, but I'm going to leave it like that for now. Okay, next thing I'm going to do is subtract the function. So that means minus x plus 1 over x squared. All right. This is still all over x. I haven't even put that part in. But since it's already a fraction, sometimes what we'll do is instead of all over h, we might just out at the end put it times 1 over h. It's going to work the same way, but it just looks a little cleaner. Okay, now I can't do the direct substitution because that 1 over h is the same thing as having this. So there's nothing I can do here without also doing that, and I'm not allowed to do that. So what I want to do is I want to clean it up and hope something will cancel. So our strategy with fractions is to get a common denominator and merge those together. All right, so we've got some algebra ahead of us here. The left side needs an x squared. The right side needs an x plus h squared. Oops, x plus h squared. Okay, so here's what that's going to look like. I'm going to have to multiply this by this whole quantity. So it's going to be an x cubed plus x squared h plus x squared over, and here I'm going to write x squared, and then it's going to be times this x squared plus h squared, which remember is x squared plus 2xh plus h squared, minus, okay, a little wormier, it's going to be this x plus 1, and it's going to get multiplied by that quantity squared, which is x squared plus 2xh plus h squared over my common denominator, x squared plus 2xh plus h squared. All right, got it. Still all times 1 over h. Now, this problem is obviously a little lengthier than the others. So I feel like I'm trying to go slow enough with this that you're following my algebra on it. But because I'm doing that, we're going to have another step here of the limit. We are not ready to evaluate that limit because I haven't even got that h to cancel or anything. All right. Now, options. Let's see what we've got. In the denominator, do you want to distribute your x squared through? We can, because I'm going to merge these together. I've got the common denominator. I'm going to go ahead and merge those through. So that's going to, or distribute that through. That's an x to the fourth plus 2x cubed h plus x squared h squared. That's my common denominator. Now, in my numerator, I have another multiplication step that needs to happen right here. So, and I have this minus sign. So I'm kind of nervous about this, and that's sort of why I broke it down into 2 steps. I'm going to have to take this and distribute it all the way through, take this and distribute it all the way through, and make sure all of them end up negative. All right, so I'm going to write the first one. It's just an x cubed plus x squared h plus x squared. Now here we go. I'm going to take this x times each one of these, and I'm going to make them all be negative. So that's going to be a negative x cubed, a negative 2x squared h, and a negative xh squared. Now I have to take this 1 and distribute it all the way through and make them all be negative. And the 1 over h is still out here. Now I'm ready for all the simplifying that I want to do. All right. Hopefully a bunch of stuff's going to cancel. What we got? Here's an x cubed. Here's an x squared. These are actually like terms. X squared h, x squared h. Those could combine together. Are there any others like that? I don't think so. But these two, if you combine those together, would get you a negative 1 x squared h. Okay. The other thing I'm noticing, though, is that everything left in the numerator does have an h in it. So this h is going to be able to reduce with each one of these terms that are left. Okay. So here's what I've got. I'm ready. I'm going to actually clean it up. So as I said, we're going slow enough. We got to write that limit a few extra times here. Don't get to stop writing that until you actually evaluate the limit, when you actually plug the 0 in, and we're just not quite there. Okay, so here's what I've got. I've got this and this are going to get me a negative x squared h, but that h is going to cancel, so it's going to be a negative x squared. Then I have this term. What that h is going to reduce, so it's going to be a minus xh. The next term is right here. That h is going to go away, and I'm just going to have a minus 2x. And then that last term is going to be a minus h. And this is all over your common denominator. Did you write small? I don't think I wrote small enough because I still am not quite there. I'm ready to write the derivative. We're going to plug in 0. So finally I get to stop writing the limit, and I'm just going to write my answer. Here we are. Actually, I'm going to change colors on this because I'm afraid it's going to turn into a mess. When I plug 0 in for h, I'm going to have a negative x squared. Next term's gone. Minus 2x. Next term's gone. Over, when we put it into the denominator, it's going to make the first term just be an x to the 4th, but the next two terms are going to go away. Okay, this does not match any of my options up there, but it sort of goes back to, we just haven't put it in the same form that they did. What they're choosing to do is separate it into two fractions. So I can do that. I can separate it into two separate fractions being divided by that x to the 4th. So it's a negative x squared over x to the 4th minus 2x over x to the 4th. And now I can reduce, which it looks like they probably did. Negative 1 over x squared is what that term reduces to. Minus 2 over x cubed. All right, how about that? Does that match? There it is. It's A. We got it. That's a good feeling when you see the answer there. Okay, so all multiple choice. It starts off easy, and then you're going to get some more challenging ones like this. So have fun with it. See ya.